Hello everyone, today we are going to talk about loss elimination ratio. Loss elimination ratio LER is defined as the proportion of the expected loss that the insurer does not pay as a result of an ordinary deductible. So LER with D as the parameter is equal 1 minus expected value of X minus D plus over EX, which can be further deduced to be expected value of X capital D over EX. So this number gives percentage of the expected loss that the insurer saves. So when the insurers impose a deductible on the policy, essentially they are saving the money. So they want to know how much they will save when they impose these deductibles. Let's look at some examples. First example, an insurance coverage has an ordinary deductible of 500. Losses for a two-parameter distribution with alpha equals 3 and theta equals 1000. Calculate the loss elimination ratio. So based on this given information, first we know that the expected value for this parameter Pareto distribution is expected value is E, and E capital D is equal theta. This will be given in a formula sheet. So as long as you know this formula, this question is very easy to answer. So let's get the LER calculated. LER is equal EX capital D over EX. This is the formula we had in previous slides. So this can be further because this and this cancel off. This become 1 D plus theta alpha minus 1. Then all you need to do is apply the numbers into this formula. You can get LER is equal 0.556. Yeah, for those people that are not familiar with distributions, this question actually tells you that you shouldn't be panic because all you need to do is apply the numbers to the formulas. You will get the answer. So even though you don't know the distribution very well, you don't know how it's going, as long as you know how to apply the numbers to these formulas, you will get the answer. So anyway, the question for the second one is calculate the loss elimination ratio after 10% inflation. So this is just a concept of inflation applying to what we have learned so far. Basically, the gist is just you apply the factors to the variables and you pull that factor out of the equation. And really, the rest is still applying the original distributions characters. So that is not very difficult as long as you know how to utilize these factors. Expect value of E plus R, which is inflation. You pull this out, and basically it becomes this. So 1.1 EX. Similarly, if we are talking about expect value of 1 plus R times X, but the capital D, when you pull this 1 plus R out of the equation, you have to put this D divided by 1 plus R. So D is 500, now it becomes 500 divided by 1.1. Once we have both ready, LER is the same thing. Expect value of X capital 455.4455, which is 500 over 1.1 divided by EX. Then you will get the result. So I'm not gonna explain further, but if you are not very familiar with this part, You can also refer to the notes because notes is slightly better handwriting than mine. Now let's look at example 2. Determine the loss elimination ratio given the following information. Deductible is 250. Let's write everything. So this is D. Expected size of claim with no deductible is 250. This tells us that expected value at EX is 250. The third one, probability of a loss exceeding deducted is 0.95. So this is probability of X greater than D, and D is 250. And the last one is mean excess loss of the deducted 2375. So this is expected value of D, which is E X D plus, given that X is greater than D. So this is further with the formula we know. So Px over D greater than D is 0.95, and ED is given in the 2375, and this is 0.5. So from here we can get the expected value of X minus D plus is equal 2375 times 95, which give you 2256. From here we can determine the loss elimination ratio. So from here we can get the loss elimination ratio is expected value of X or capital D over expected value of X, and this is further can be deduced as 1 minus E X minus D over EX. Then this is no, then we can get the final result 0.975. Again, my deduction process is slightly simplified. If you are not understanding part of the deduction, my notes has slightly better explanation than this one. You can refer to my note. Okay, let's look at the third example. Loss is a follower distribution with mean 2000. So let's write it out. Expected value EX is 2000. The loss elimination ratio LER at the deductible 1000 is 0.3. So LER is 0.3, which is this EX. This is the formula for loss elimination ratio. 60% of the losses in numbers are less than the deductible 1000. So this tells us the probability of X less than 1000 is 0.6. Determine the average size of a loss that is less than the deductible 1000. So it's asking, what it asks is EX X less than 1000, because it says average size of a loss that is less than deductible 1000. So this is the question they are asking. So this is not very straightforward because it's not applying the formula directly, but what we can do is like think about what else we know and how are we going to apply all the informations. So here is the part that you should know in order to solve this problem. Expected value of X capital 1000 would just be expected value of X as given X less than 1000 times the probability plus expected value of X greater than 1000 times the probability of X greater than 1000. So once you know this, then expect value of x given x is less than 1000 is this part. Then all we need to know is trying to figure out this part, which is already know, and this part, which we already know either, and this part expect value of x given x1 greater than 1000. But if x greater than 1000, the expect value would just be 1000 because it's capped at 1000, right? So from here we can just apply this formula. Expect value of x. From here we first need to find out is the expect value of x capped at 1000, which can be deduced by this part. LER is 0.3 and EX is 2000. So this actually tells us that the expect value of x capital 1000 is equal 2000 times 3, so it's 600. So once we get that, this part and this part is we know probability of P is 0.6. And this part, probability of x greater than 1000 is just 1 minus 0.6. So everything else is null. Then we can calculate this expected value of x given that x is less than 1000 to be 333. So it's solving the problem using the given information. So when you encounter this kind of questions, don't panic. All you need to do is write out what you know and write out the connection between the question and what you know. Basically, this formula here is critical for you to answer the question. You have to think about it using the expected value, the concept of expected value, then you should be able to resolve the issue. Now let's look at some loss elimination ratios for certain distributions. First, for exponential, LERD will be equal to 1 minus e to the powerful negative d over theta. Why is this? Let's prove it. LERD. First, this is the formula we should know by now because we have been using this formula for a long time now. And expect the value of x capital D, this can be found in your formula sheet to be this. And Ex is just theta. Therefore, you will get this for the LER. The second one is the situation when it's two-parameter Pareto with alpha greater than 1. Then what's LER? What's loss elimination ratio? So first we know that Ex in for two-parameter Pareto distribution is this, and Ex capital D is also given in the sheets is this minus 1 plus. We actually did a similar exercise earlier in the example. This is just a review in that sense. So now LER D will be Ex capital D over Ex. Now this part will cancel out and it's just 1 minus theta d plus theta. So alpha minus 1. Okay. This is just a very simple deduction of the LER for two-parameter distribution.